Hi, my name is Caterina Scambio de Castilla, and welcome to the first and maybe last OME meeting in the US. We'll see how things go. But thank you for everybody that braved coming here, and if you couldn't, then we're glad that you're joining us on virtually. Oh, is there any way that we could have that thing not be there? Oh, this, well, gonna be there. Okay, so first of all, there is a new, one of the points of having the meeting here, this wonderful place, is that we want to have more people coming to the meeting, so it's great that there is new faces here. It could be a little bit intimidating at the beginning. There is a lot of software development being discussed, and there is a lot of people that have met for a very long time, and people know each other. So, first of all, please feel really welcome. Everybody's really here to welcome new people. And I think the real great thing about this community is that we are all learning and teaching because everybody is at the same time. Because everybody is either more an expert on something is slightly different, and so we're constantly learning and teaching. And as we go, this is a constant. So you're in good company if that's how you feel. Oof. Okay, sorry about that. Okay. Yeah. So then everybody's kind of trying to help each other and walk in somebody else's shoes and trying to help the issues that everybody has. So this is why I love being here. Okay, the first session that we're talking about is that I'm and the pleasure of hosting is about how do we get people to start sharing their data from the ground up. So first of all, how you produce data that is ready to be shared, so that when you get there is not too much of a pain and people end up not actually being able to do it. So we want to build if we want to build an image data internet, we need to definitely build the networks of repositories that are needed for sharing this data. And there's going to be a session talking about this part. But then essentially, there has been multiple publications about this. But the thing that we're going to talk about in this session is about actually how do you end up generating that data from the ground up so that it's ready to be shared when you need it. So, and the argument here is that most data around there is not shared, is not fair. It's not really ready, is all over the place. So we really need to help people get to the point in which they are able to share their data. So we need to work at the local level to build usable integrated infrastructure for pre-publication data management and sharing, so that they're ready to then share when they want to share, and that then there are networks of interlinked networks that of support hubs, so that we can help each other get to that point, and then work in the community to continue promoting standards and standard tools. So in this, we're gonna have 4 speakers, including yours truly. Judith is joining us virtually, and she's gonna talk about what QUAREP-LiMi is doing to help people share quality control data. Valeria is gonna talk about the effort of doing this, helping people with their data at NYU. And Michelle Itano is doing the same similar things in North Carolina, and I'll tell you about what we're doing at UMass Chandler. Okay, thank you. And we're gonna go to Judith.
All right, thank you very much, Katrina, for this introduction. I'm gonna start sharing my slides, and I will not be seeing you, so you'll need to talk if you need to grab my attention.
We can hear you very well. So.
Sorry?
You can hear you very well, so go ahead.
Super, excellent, thanks. All right, so there you go. Hello. So yes, I'm Judith.
Sorry, can you put in present in, can you put in,
I am in presentation
Okay,
mode.
I am. Yeah.
Is it okay?
Yeah, perfect. Okay, sorry, it was me.
Okay.
Go ahead.
All right, so I'm Judith. I will be talking about quality control, metadata, and data management based on the QUAREP organization and what how we use the Canadian Alliance for doing that. I'm from a small business called Microscopy Imaging Analysis Cellavie, and I work a lot with the organizations that you're seeing below the slide here. So thank you for your attention and thank you for the invitation. So in today's presentation, I'll describe briefly what Cellavie is and how it got me into quality control and data management. I'll describe what quality control measurements are for microscopy equipment, and I'll talk about how we handle the data generated by these instruments, these measurements. So Cellavie from the very beginning believes that robust answers to scientific questions demand artifact-free, reproducible, and quantitative microscopy. And we've been doing everything to make that happen. And obviously we need to share that information with our customer, but also with the community. As a small business, liability insurance coverage is extremely expensive. So this forced us at many years ago to put a lot of effort in documenting everything that happens to in Cellavie, including data acquisition, management, and so on. So that's how we got into data management and quality controls. Back in 2011, we had the biopharmaceutical industries reported about reproducibility issues with science, and Cellavie was hired for one of them that involved confocal microscopy. So I'm just going to briefly summarize this project to show you how I ended up working a lot with open science. So this study demonstrated that there was a statistically significant correlation between the number of metastasis tumors and the fibronectin fiber orientation. In the original publication, this was a positive correlation, while in the negative, it was negative in the replication study. And really the conclusion was that this was brought about insufficient metadata reporting. So very briefly, we inject tumors into mice. When these mice express a molecule called caveolin, we get more metastasis. These are the organs that are shown in the Petri dish. And when we section and stain those tumor cells for extracellular fibronectin and intracellular actin, we see a change of fiber orientation in presence of this molecule, but not in its absence here and here. Again, positive correlation in the original study, but negative in the replication study. So why is that? Insufficient metadata and reporting is really the culprit. We had a lot of information from study and study component, but obviously for biosample, we were missing quite some information because some of the, here the actin staining, we could simply not reproduce. We were able to reproduce the fibronectin staining, but we did not have access to any raw images, so let alone the metadata associated with them, and we did not access to the analysis results and nor the analysis workflow. So what are these sources of reproducibility? This is one of the examples of the replicated image. It's an image of fibronectin fibers. This is just a mask of the thresholded images. In the original study, we knew that there was a maximum of 500 objects that could be detected, whereas in the replication study, we had between 10,000 and 15,000 objects being segmented from following their procedure. So there was obviously a problem. And what underlies that problem? Well, again, there could be several factors, but I can tell you that if we're doing intensity measurements, if we're looking at object segmentation and looking for we are looking for these fibers, but we're also picking up a lot of small objects and so on. Obviously, the QUAREP-LiMi protocols from light source intensity, detector performance, and objective performance are possibly a source, an important source of factors for this lack of reproducibility. Okay, so what are quality control protocols? And essentially what we're trying to do is measure the quantitative performance of instruments. That could be the same instrument over time or comparable instrument. And what we really want to have is a window of expectation. So obviously there'll be differences, but they cannot be 100 or 200-fold differences. This does not come out of the blue. If you consider the confocal listservs, the poly and AQLM courses, the ABRF, and many other publications, all these this documentation from the community evolved into the confocal ISO norm 21073, and communities like QUAREP-LiMi, Global Bioimaging, and BINA are working together to help the people implement those controls into their routine work into core facilities. So the other take-home message that, hold on, yes, so this is an example of a data acquired for measuring the detector performance. For example, a microscope that was under our care, we measured the read noise, the performance of the detector back in 2009, and you see a nice linear response here. The intersect at here gives us an idea of the read noise, and we can calculate the photoelectron conversion factor from the slope. If we repeat this measurement few years later and we get this, we can see that we have a problem. And in this particular case, we were able to advise and work with the people and find a solution. The bottom line is that quality control data is imaging data for the great majority. And Omero is actually a really fantastic tool for handling data management in the context of quality control. So I'm based in Canada, and here's the situation for Canada. We have an infrastructure put in place by the Digital Research Alliance of Canada. On the west coast of the country, we have a virtual machine running our Omero instance. And I'm based here in the province of Quebec. And I interact with this instance back in Canada. I also interact with many other Omero instances. But what I want to say here is that in the province of Quebec, we have advanced research computing clusters that are provided by the Alliance. And all these resources dispersed throughout the country are connected by a high-speed connection. So we have a nice infrastructure for organizing our data with Omero. So more specifically for organizing quality control data in Omero, first I want to go over very briefly how we're doing this for the instruments located in Canada. I want to give credit for the idea of doing this to Julio Mateos Langarac and as well as Steve Ogg. We're all decided to take this approach for organizing quality control data into OMERO. So the group corresponds to an instrument. Now we need to come up with a unique identification scheme for the instrument. Cellavie has done service on over 600 different instruments in the regions of Montreal. And I know very well how we need to get organized into our naming scheme to rapidly find an instrument. So the group is the instrument, ROR, RRID if they are available, room number, highest modality possible on that instrument, and the stand serial number. The projects will mostly be quality control protocols, as well as a number of different images that are used during various interventions on the microscopes. Photos of the systems are useful, and we also use Micrometa app, and we have a folder for that. The data set corresponds to an actual microscope image acquisition time at the microscope, so the data that is outputted by the microscope, and we have the corresponding analyzed data to track this information. I also want to mention briefly here that OMERO does not capture everything. So Cellavie uses a CRM software, customer relationship management system, that links to the OMERO datasets. So we work heavily with Micrometa app, where we have it as a plugin on the Digital Research Alliance of Canada, the instance there, as well as the MIA Cellavie instance. This is a collaboration, obviously, with Katrina. We will attach the JSON profiles are attached into the database, and a copy is also attached into the specific group of the instrument we're working with. Many of you will say that Micrometa app is not for confocal microscope. That's true. But even as it is right now, it's actually super useful to capture information about sources, detectors, fluorescence filters, and the microscopy, the objective lens. So it's super useful, and we use it a lot. This is one of the success story for MIA Cellavie. This is one specific instrument that has been under our care for 14 years. We have, again, the group, the project with the various QUAREP-LiMi protocols, both the unprocessed and analyzed quality control data. We can, when we do the analysis of the quality control data, we can attach the workflow directly to the data sets and rapidly find the information. As I say, we do these measurements over time, and it's important to be able to track in time what's happening. And again, we have our Micrometa app profile. So we're collecting what is called the microscopy metadata there, but there's remains to be more metadata to be collected. Namely, well, first we would like to automatically collect metadata at the time of upload, and we also need to collect sample preparation metadata that pertains to the quality control measurements that we're doing. This is super important information to capture. Therefore, I hope I was able to convince you. Well, first of all, I have a typo here, but the recommended metadata for quality control is part of the recommended metadata for biological images. Quality control data is critical for reproducibility. The data has recommended metadata. If you consider the QUAREP work group, we need a number of input metadata to properly analyze the information. But this information, the output, the result of the QC analysis is output metadata. And we also need to capture this information. And this output metadata for the quality control measurements, I dream to have this metadata become the experimental metadata in the future. So yes, OME is a great data management tool. We use it also for quality control measurements, but can we improve to better present and or capture metadata? So I'm gonna finish here with a bit of my wish list for the future work on OME. For example, maybe we could convince the manufacturers to include ORCID in the image metadata, and that would be very convenient. We already know that we have the person, the experimenter coming up in the data model, but having the ORCID maybe could be an easy step. And could we harmonize microscopy modalities? This is really painful for QUAREP quality control data management at the moment, because there's no harmonization. In the NBOQ model, we have those terms coming up. In FBBI, we have those terms. I actually was not able to find wide field fluorescence in there. Maybe it's just me, but someone can point it out. And we have EDEM bioimaging also has those terms. So harmonizing would be really fantastic. So again, my wish list: expose and present metadata that's already in NBOQ, handle the quality control metadata input versus output, and integrate the quality control data output for becoming experimental metadata in the future. And I'm going to end here by saying a big thank you, acknowledging the team, the number of people that are collaborating into this project, and I'm happy to take questions at this stage. Thank you.
Judy, can you hear me? You're muted, but yeah. Thank you.
Yes, now I'm hearing you and I'm not muted, sorry.
We have time for one quick question if there is. Otherwise, we have more discussion time at the end.